Okay, this is the tutorial for the Z class? Yes. Z class, if you looked at the previous video uploaded, you'd see that we did this also for the Year 9 class. The main things we're going to learn this lesson is we're going to learn about new bodies or multiple bodies. We're going to learn how to do patterns, the revolve tool, the sweep tool, and then the orthographic drawing. This is the car that we're going to get to at some point. During the lesson. As you see here, we have our core flute and our wheels, and we're somewhat getting our pulley belt, but we should have extra time in this tutorial. We're going to also try to get the pulley wheels as well. That should be pretty cool. So I'm going to make a new design over here, and I can call this, can I right click? No, I can't, never mind. So we're going to start by sketching my piece of core flute. Now, you all got a piece of core flute. And the size of your core flute, if we press the rectangle over here and start it from the center, your core flute should be 200 by 100 was the size of your core flute. And you see here when I click it and I zoom out, you can see how that's a darker blue in the middle there. That means it's a closed surface. If you did a rectangle, it should always be a closed surface. If you did it by individual lines, you have to make sure that you end and you close the shape, otherwise you can't turn it into 3D. But this is my closed surface I have here, and then I can press Finish Sketch. This is a 2D object. If I press my Home button over here, this is a 2D rectangle. I have to make it into 3D, so I'm going to press Extrude. By default, it's picked this because it's the only shape in my design, and the distance I want is 5 millimeters. And then I press OK, there we go, there's my 5 millimeter piece of core flute. And if I go to bodies here, it's called body 1. We are going to actually start renaming this now. Instead of body 1, we'll call this core flute and press enter. So we're going to give it a name because we're going to get multiple bodies here. Unlike your tower where everything was balsa wood, now we have different materials, so we can actually start naming things differently, and we're going to copy some pieces, we're going to color some pieces. So if we have it named, it's going to be easier for us to identify which piece is which. If we right click this core flute, we can go to Appearance and press that button. It loads up this Appearance menu. What color is your core flute? White, okay. If we press white, we have a bunch of here materials. Now we don't have actual core flute here, but I mean core flute is pretty close to ABS plastic. In fact, I don't know what core flute's made out of. It might be, but something tells me it's not. It's probably PVC based. But it doesn't matter. If I press ABS white, if I drag this over, now my sheet is white to make sense. And I can close this. So that's my piece of core flute. Now, what is the big difference between this piece of core flute and your piece of core flute? What's different? The holes, exactly, yes. So we want to make the holes in this piece of core flute. We're going to press this sketch button. We're going to press one of the faces over here. And we just have to make a little square in here to represent the holes in the core flute. So we can press a 2-point rectangle and we can pick any particular shape we want. Now this, I'm deliberately not doing a good square to show you that's pretty bad, right? We can make a better looking square. So if we want our square, we can press this sketch dimension tool over here, which means we have some lines and I want to actually define them as a proper length. So I click the sketch dimension tool. I want to click this line up here and I want this line. Now I have 4 millimeters, but let's say I actually want it to be 3 millimeters long. And let's say I want this height to also be 3 millimeters. So now that's the shape that I have there. But I also have like the thickness that I want between the walls. So I can do that as well. With the sketch dimension, I can press this side and this side, and I can also make this equal to 1. So now that's 1, and I can make this and here, and I can make that equal to 1. And so now that's the square. Right. I could finish my sketch here. I could do this and I can do all the individual squares and then extrude it, and that will make the holes. But as we zoom out, we see there's a lot of them to do. That will take time and effort, and instead we're going to use the pattern tool. create. Now I believe when you did the pattern tool for the tower, you did it when it was in the body form. This time we're going to do it in the sketch form. Slightly different, but it's also pretty similar. We're going to do a rectangular pattern. We are going to select the objects we want. So it's not the whole body this time. We've got to pick like sketching elements. So it'll be these 4 lines are the sketching elements we want. And then if we drag this particular thing, we're going to get 3 of our squares popping up here. Now over here, the option we have, so let's say I want it to be like this, and I want to increase the number. See how it's making more squares, but it's not making them longer. Because the option I have here is distribution, I have extent. So I pick the total distance, and as I'm increasing that number, which right now it's 7, it's saying how many squares do you want inside there. Maybe you want that. Me, I don't really want that. I want the squares to all be the same distance apart. So instead of extent, I'm going to press spacing, and then I'm saying how far do I want each square to be from each other. And I think I want each square to be -4. Each square to be 4, because that means the square is 3 millimeters plus a wall is 1 millimeter. So every 4 millimeters, repeat this process. And we see here, this makes sense. These squares look like there's an even boundary around them. Now I can just keep increasing this number. Right now, I think I remember from my last class, I think it was 36. Not more than 36, 46. 52. 52, I can, it doesn't matter how far you go over, or if your thing is only partially over, because, I mean, honestly, the way I cut your core flute, that kind of makes sense. Some of you have pieces that are perfectly cut, some of you have the end sticking off, and actually, if it's open like that, it kind of makes it look more authentic and good. We'll press OK. So now we have a bunch of squares over here, and if we'll finish this sketch. Now if we want to make this hole inside our core flute, we can press the extrude button, and we can press this particular thing here. Now remember from extrusion, if it's blue, it's going to make a solid object. If it's red, it's going to make a hole. So there I can make a hole in my core flute. Now, and for my profiles, I can actually press all the squares, all 52 of them. But that takes time, and as they get really small, you might click them, and you know what, who has time for that? Instead, what we're going to do is we're going to press the profile as the outside. So over here, notice it's cutting the whole outside of the core flute, and we're left with just the rods. So instead of the cut operation, if we press the intersect operation, it's saying, like a Venn diagram, the parts, that was the original part, and the part we're extruding, just where they overlap. So this should just be the outside of our core flute. As a general note, the color, if it's blue, it's typically extrusion. If it's red, it's cut. And if it's yellow, it's saying this is an intersect command. And then we press OK. And look, now that's looking like our core flute. All right? And we can even go slightly better now. We can even make it look nicer by, let's say, we have our core flute, and what do we want to do? Let's say we want to, say we want to do this shape over here. And I want to do this, what was that? Was that 2? Say I want to, like, you know, make the front slightly more aerodynamic. I press OK, and I believe now we can, the investment we did of making all these little holes is going to make this look really nice. If we go to extrude, we can press that surface, and watch what happens as we cut this. Ooh, nice, we have the nice little core flutes showing up there. Cool. Now, the next thing of our car is we will make one of the axles. So the axles of our car are going to be inside these holes. So what we're going to do is we're going to press sketch, and we can either sketch on this surface, or we can sketch on this plane over here. I'll do it with the plane. If I try to sketch on this particular plane, the issue we have is as I try to do the circle, is it doesn't want to attach to this object. See how it's not actually attaching to this line? And that's a problem if you want to make something look very precise. So to attach something to the drawing, we have to say, I want to include that shape in this drawing. So I press include and I press that shape, and now we have these purple lines. If I try to make my circle, it's like attaching to there. We see that little triangle and that X symbol. So it means use this geometry to adjust my circle. I want to make this hole here. I can make a circle. I can try to get the midpoint and try to guess where the midpoint is. I can also get two lines, like over here I have these blue dotted lines. You can do that. But I may as well show you a new tool. You can also, when we press circle, we have several objects for circles. If we have 3 lines, like our square, we can make a 3 tangent circle. Where I can say I want this line, and this line, and boom, then we get our circle. So it fits perfectly inside that particular hole. Press OK, finish that, wonderful. We have the beginning of our axle, and now we can just extrude our axle. Do you remember the size of our axle? 120? I think it was 120. So if we press this button over here, we can extrude it. So for 120, means we can put 10 millimeters on this side, and then this is going to be 100 millimeters. We want it to come out the other side as well. So when we do our extrusion, instead of one side, we're going to do 2-side extrusion. And then we can drag this one over here, and this one will be 110. And so then we will have, that's our axle in our body. Okay. All right, now let's get to the real exciting stuff. I'm going to hide these bodies just to make this current thing easier. We're going to make the wheel. So the one method of making the wheel is, this is the boring way, and I'm going to delete this way. But we can make a circle, right? And we can extrude this circle. Bam, that's our wheel, right? We can do that. Right, very simple, but looks kind of mid, right? We can make this look better than that. So instead of that, what we're going to do is we are going to make, let me just check what sketch plane I'm in. Instead of that, what we're going to do is we're going to make half of the circle, and we're going to spin it around. We're going to use a rotation. It's going to allow us to make a much more interesting wheel. So, do we remember the dimensions of our wheel? The other class told me it was 50 by 20. Does that make sense? Something like that? 50 millimeters diameter? 20 millimeters thick? Okay. So, if we're doing half of the wheel, that means this length down here has to be 50 divided by 2, because we're doing like the radius. And the height can still be 20. So that's going to be what our wheel looks like. But we can also make it more interesting, this revolve tool, because it's a revolve tool. So what we're going to do is we're going to add some more features to this wheel. We can use our fillet. If we press this length, and then this length and this length, we can press 1 millimeter. It's going to make the corners rounded, which more represent what our wheel would look like. And we can also do something like this, where we can make a little rectangle like 1.5, and that can be 0.5. We can make this little groove inside our wheel, and then we can use a rectangular pattern. We can select the shape that we just made. 1, 2, 3. And go to extent. We can drag this down. So what I'm doing here is I'm just making some grooves in the wheel. We can also say, let's say our wheel's going to have like our wheel has that bit of the recess in the front where it's silver. So we'll make it nice, and we'll make it look very nice later. We can go here, we can go down 2 millimeters, we can go we can make that shape, and we also have our axle is the inside of the wheel is actually hollow, right? It's not a solid object, so we can make that in here as well. I'm just guessing these particular shapes. That's what the inside of your wheel probably looks like. So that's, if I was to cut the wheel in half, that's what half of the wheel would look like. I finished that, finished sketch, and now this is where the magic's going to happen now. We're going to press the revolve tool. So let's just have a look at what it says with the revolve tool. Revolves a sketch profile around a selected axis. So I'll do that. We'll select this sketch. We're going to revolve around this. We made this line down here in the middle. This is why we made half of the wheel, not the whole wheel, so we can revolve it around the middle. And if we press this axis over here, boom. Ooh, there we go. Now that's a nice looking wheel. It's much nicer than the cylinder we had before. Now, to visibly show you, in theory, you don't have to do the whole revolve tool. You might have another point in another task where you don't want to, but here's what the revolve tool is doing. It's getting this shape and it's bringing it 360 degrees like that. So it allows you to get that much more interesting looking geometry. And okay, so let's go back and let's label our things here. This over here, this was axle. And this over here was wheel, okay? And we can even, I don't like this being silver. Do I have rubber? Oh, I do have rubber, hard rubber, there we go, boom. The wheel should be like black now. We can even make this inside bit silver if we want. We can make a shape here. I think I've done. We can extrude this mini surface we have here. How far do we want to extrude it though? So 0.1. And I don't want to join this. I want to make this a new body. And press OK. And this one, we can call this, what would this be called? A rim. Not rib, rim. What color is your rims? Silver, yeah. Pink? Well, you can make yours pink, that's fine. Silver polished, let's just say that. Oh, nice. So let's say our silver rims. And you can even do patterns in that if you wanted to, right? So we have this wheel, but it's not in the right position, is it? No, it is not. So if you want to move this stuff, well, one thing we do want to do, we do want to make sure that when we move the wheel, we also move the rim. So the first thing we're going to do is I think we can click these two together, right click, get rid of appearance. I'm just pressing escape for a bit. I think I can press this and this, and then right click, and then I can move to a group. Don't want to just align them. I want to, I guess we can deal with it later. We can move them around later. Okay, so we have the wheel and the axle, and we want to move the wheel onto the axles. Our options are, we can press move or copy. If I press this particular body, right, so to move an object, we have to first say where we're going to move it from. Now, in the X, Y, Z directions, it doesn't actually matter a lot, but what it does matter is rotation. If I want to rotate the wheel from the top of the wheel, it's different than if I rotate it from the bottom of the wheel. So I've got to select somewhere on the wheel that I'm going to rotate, and then I can just move it in all the directions that I want around the particular object. One of the problems is you have to perfectly align it, but there's even a way we can do that easier. We can use the align tool over here, which if we have some geometries that we know that are good, we can align them up. So this one, we know the middle of this tube over here, that is going to be aligned with this over here. And then it moves the wheel over there. Same thing with this silver disc that we just had. This silver disc. No, not that one. this silver disc is going to be aligned with here. Ah, that's not good. There we go. So now we have the wheel over here for the car, and we can also, now that we have this, we can make a copy of it. We don't have to do this wheel again. So we're going to move to the move or copy thing. As I select these bodies, and I can actually select more than one. I think I can press both. I have two bodies selected now. If I, notice how here there's this button that says create a copy. If I start moving the object, the create a body thing disappears. Sorry, create a copy disappears. You can only create a copy if you haven't moved the object yet. I don't know why Fusion works this way, it just does. Because once you make a copy, then you move the copy around. Right, so that's what you're doing there. You can move this. You can even rotate this if you want to make it go in this particular direction. Now we can do the same trick we did before where we can align. We can align those two, and then we just have to align this particular disc again. One of the problems of making this rubber is it's harder to see. There you go. So we have those discs here. Cool. Now, when we're making the motor, we'll make the motor as well. Let's say you just want to sketch it in this plane over here. I'm just picking what I think the motor looks like from my visual guess. You have the advantage that you can actually measure your motor, but the motor approximately looks like this. It's just a circle and a square is your motor. Now, one of the reasons why we made the core flute white, or I like to color the objects if I'm doing a complicated thing with multiple bodies, is I have the motor here. If I'm trying to make this into the 3D, notice how the motor is also white. So this is a reminder, hold on, this is saying that the motor is the core flute, but the motor is not the core flute. So I have to make it a new body, and that's when I can change the color of the motor if I wanted to do that. Cool, I have my motor done. I can also make the shaft of the motor. For this particular one, I'm not that concerned if this shaft is the same color as the motor, because it will always, you'll always move the shaft with the motor, but you can move, you might move the motor to a different area on your body. And we'll just extend that out. I think it's like 8 millimeters or whatever. Cool. So now we're going to do the rubber band that you saw in the other drawing. So to do this, I'm going to hide some things. What do we need? We want the rim. No. All we want is the axle, and we want the motor, because that's what we're going to look for where we're doing the rubber band. And while I'm here, I may as well rename this motor. Cool. So we're going to go to sketch. We'll sketch in this plane over here. Some things we're going to need is we're going to need this circle and this circle. So I'm going to press project and include. Project, we want this circle. And we want this circle, because that's where our belt is going to go. Okay, and so do we remember the diameter of the small circle? Anybody remember? By any chance? No? I think it's like 14. No, it's probably smaller than that. It's probably 12. 12, I think, is the diameter of the small circle. So we'll put that 12 there. And the large one was like 42 or something like that. I don't know, approximately. Yours could be different. So I have these two circles. And so this rubber band, if you imagine you had a circle with a rubber band, the rubber band's going to be part of the circumference, but then it's also going to be the tangent of the two lines. So if I could perfectly design it, if I could just perfectly design a line that went like that, right, that'd be great if I could do that. And you kind of can in Fusion. You have this circle and this line here. Now I believe we can we have to first make sure this circle isn't going to move. So we'll press the concentric button, and we're going to press this and this circle. Oh, never mind, it's already been done. So with this line, we want this line to be touching. So under the constraints here, we're going to use the tangent constraint. If we click tangent, and then if we click this line and this line, now that line is in a tangent to that circle. And then we can do the same thing over here. We can press this line and this circle. Oh, I did something wrong. This line and this circle, and there we go. So now, and it even has this little white icon here, so now this line is in tangent to both of those circles. We can do the same thing down the bottom, and let's just do a really offline. There we go. And we can do that same thing, tangent, this line to that circle, this line to that circle. Cool. And the other thing we need to do, it's going to make our life simpler, is we're going to trim the excess. It just will make our lives easier. And we'll also trim the inside parts of the circle. So now this is like our weird looking ice cream cone that we have here. And this is the shape that our belt will make as it goes around our two pulleys. We'll press finish sketch. So now we have this particular shape, and that's going to be the path that our object will follow. We need to now make a diameter, like a circle that is like the diameter of the inside tube of the rubber band. So to do this, the way I thought was the easiest way to do it is we first have to make a plane to do our sketch. We're going to go to construction, plane along a path, and if we press this path that we made, it doesn't matter where in this particular drawing, but in theory you can drag this anywhere, but just pick a place. And what we're saying is this is going to be the 2D shape. This is going to be our 2D circle. It's going to be on that flat drawing board. Okay. Press that to do a sketch. I don't know what the diameter of the rubber band is, but I'm assuming it's 1 millimeter just for this drawing. You can obviously measure yours. Press finish. So we did all that work just so we can draw this little circle. Just so we could draw this little circle up here. So see how that's going to be like the cross section of the rubber band as it goes around? Cool, so now we're going to use the sweeping tool. What the sweeping tool does, it sweeps a sketch profile along a selected path. So it's like it gets the circle, and so I get this circle and make it drag along a particular object and do that shape. Imagine like if I had paint on the floor here right now and I got the broom and I swept it into a particular shape, it's going to follow the shape of where I move the broom. So we'll do sweep. How we do sweep is, once this loads up, we need to select a profile. The profile we want is this circle. And the path we want is this lovely ice cream cone shape that we made here. And now, oh, look, we have a shape here. We don't want it to cut into this particular hole here, so we can just press new body instead, because we can also name this. But there we go, now that's our pulley. Our pulley is done, and we can even name this. Pulley. Yep, and then we will choose this pulley. We're going to move this pulley out a bit. Just a little bit. So it's not inside that wheel. Okay. Cool. And now this is the extra thing that you're doing compared to the other class because you have time. We want to make, we can make the inside pulleys that these are connected to. So we can go, well, the other class is doing it, but they don't have the tutorial. So you got a bit lucky in that aspect. We are going to draw, we want to draw the pulley based on this particular shape that exists here. And we can do that because we drew it and we have our things in the right location. We can say include 3D geometry. We can say, well, I want this shaft and I want that pulley, and I will deal with the other one later. We'll just do this one for now. So I want a pulley that can cover over this. And now if I hide these, no, that's not what I want then. What do I want? I want, is it project? I want this. I want that shape and I want that shape, please. Thank you. And let me just hide them to visually. So that should be the shape of our axle, right? And we want our pulley to go around that. So we can do this. We can just, I'm just going to manually draw it by eye, I guess. How would be the funnest way to draw this? We'll use the mirror tool. We're going to go out here. We're going to go out to like here. We'll go out. So all I've done here is build like a trapezium. Because in fact, I've actually only done a quarter of the pulley. But I'll use the mirror tool. We want to copy this. We want to copy this. And we want to copy this. The mirror line we want is that over there. Okay, we have that shape now. We can press finish sketch just like we did with our lovely wheel. We can go and we can revolve this. We can just make sure we select all the we can press all the stuff we want to revolve, the axis we want to revolve it around. Oh, by the way, this, you're going to ask what shape. This is, I like to call this shape like a big M. You see how it looks like an M upside down? That's the shape you're going to do for approximately for your pulleys. Then if we go over here and we rotate it around there, we see that, you know, that's approximately what your pulley looks like. You can pick a particular color you want, press OK. And now if we unhide everything, well, it should somewhat, it's almost good, except it's not fully aligned yet. It's not high enough. So how do we fix that? We go over here, we press the align tool. There we go. So now that pulley, it's even got the little band going through it. I'm not going to bother doing the other one because you can do the same thing. You're just going to do that sketch on top of the little wheel. And now this car is actually looking pretty good, right? The only other things, I don't know, maybe you want to do an attachment at the top here for where you're going to connect your where you're going to attach your core flute to. So we can even do that here quickly. We can do this, and then what are we going to do on the inside? Actually, we might do it all in one go. Why didn't that work? Should have done this all in one go, probably. Right, now I've got this shape over here. Right, so I have this shape over here, and then let's just extrude this going up a bit. And I don't mind if this one's white because this is also core flute. So I don't actually care if these two are connected. And this might be, I don't know how I'm planning to connect my car to the joint. We can also, if we press wheel, I'm just going to press the shift button to hold a bunch of the wheels and rims. Is it shift? No, hold on, it might not be shift. No, shift does all of them. Okay, so now I've selected the wheels, the rim, and I think it's a control button. Yes, the control button. So now I have the wheels, the rims, and the axles. I can press move or copy, and I'm just going to make a copy of them to bring this copy down here. All right, so then I have the rear. So that's basically my car done, with the exception of you doing your wires, which I don't need you to copy. You don't have to make the wires in the drawing. But so this is the drawing done. In fact, I'm going to save this now, and this one will be 2024 drag car year 9Z. Sorry, 9Z. Yeah. Save. So good, you've done your car now. So what's the point of Fusion 360? That took kind of ages. I could already start sketching. The advantage of Fusion 360 is now that you have this object, getting it into the orthographic drawing is actually quite fast. So assuming you have your object saved, you can then go to design, drawing, draw from design, make sure everything's selected because everything's blue. Press OK. Autodesk loads up the drawing function. And there's my car. I'm about to place my car down. Before I do, I just want to check some of these options here. One is 1 to 5 is too small, so I'm doing 1 to 2. So now the car is larger. Just instantly made my car larger in this drawing. And then I'm also going to remove the hidden details, so I'm just going to go visible edges. So now I have my car. If I place my car somewhere, bam, and I press OK, my drawing's done automatically. But then what about your projected views? Because you're doing orthographic. Well, if you press the projected views button over here, say this is the view I want to project. If I just drag it up, there we have a car. Drag to the side, we have a car. Over this side, we have a car. Even down, we have a car. You know what? Even we have a diagonal car over here. And then I press the tick button to say I'm done, and all your drawings are done automatically. You might even say, well, but this is not that good because this is touching the title block, and we know that's a no-no. We don't want our drawing to touch our title block. Well, I can press this drawing, I can drag it up and down, but then it's going to align with this. So maybe I can click this view, and I can drag this to the side, and it automatically aligns my views together. So let's say I want it to be like this because I want to fit all my cars here somehow. And I believe I can even, this particular view, I want this one, I can edit the view. I want this one to be colored because I spent all the effort making my colored wheels and stuff. So I can actually go over here, I can say, give me that shade, fam. And over here, we've got the colors that our actual car is. So now in this drawing, I've got my orthographic views, I've got a nice little rendered viewing at the top. It's a bit of a bonus because it's all about communicating your car design. And now we have a title block. The title block already has a lot of information in it, like the name of the drawing was the file name that we saved it as. So just make sure you save it as a good file name that is what it is. So that automatically comes up. Things that it doesn't have here is like the scale. So you can press the text button and you can just type in here. And over here and press scale 1 to 2. You can just write your words in here. And it's a title block. And I think you can drag it around, I think. You can drag it around into certain locations. Cool. Also, you can do dimensions. So you're communicating how big a sheet you have to cut. So we can go press this dimension tool up here. You can either press, if you have a single piece that is the length you want, you can click it, and as you drag it out, it makes a dimension. Or you can do a dimension between this piece and this piece, and so then now that's 200. Now, if you wanted to do this by hand, which you are allowed to do the orthographic drawings by hand, I'm still expecting you to do these particular arrows and the lines coming out of the drawing. And when you do a diameter, you have to show the diameter symbol for your drawing. How many dimensions do you have to do? That's up to you. Pick enough that you can show me that you know how to do dimensions on Fusion. Yeah. You might want to do like how far away is the motor from the thing here. It's 107 millimeters. If that helps you do your design, great. It won't actually work perfectly because the diameter of the O-ring, we just randomly made it up. So, but you might want to get your motor and see physically how far away you can have your motor from your axle, and you can make your Fusion to be like that. You might want to show how thick particular objects are. But you do this, and then when you're done, you can press the save button, of course, but you can also export it as a PDF, or PDF is probably the best one. You can export it as a PDF, and then you can put that PDF into your report as your orthographic projection. And then if you don't like something, you can change it if you want, and then you just got to refresh the drawing, and those things should have changed. So let's say one other thing we wanted to say, let me just save this first. Save, yep. Let's say I also wanted to make, let's say I wanted to make a hole inside my thing to make it lighter, right? So I can sketch this shape. Let's say I wanted to, right, I just wanted to cut some holes in here. Let's say I didn't really have a plan as I was doing these holes. I just attacked it with a drill, maybe. Please let me select that. Thank you. And so I'll bring this backwards. Now we have our holes. And lucky we did all that work doing those core flutes, because look at that. That looks really nice on our drawing. So now if I press save here, if we go to our drawing, well, firstly, we have a warning over here. It says some changes may have been made. Up here in this top left-hand corner, we're saying here that what this drawing is referencing is an old one, a pre-saved version, because notice this doesn't have the holes in it. But if you press that link button, it should update the drawing, and now those updates are inside your drawing now. Notice here in the 3D drawing, but also over here we have the holes. Anything like, you won't have dimensions for it because you have to manually put those dimensions in, but that's still helpful if you want to change your drawing, and then you can update it. Very good if you're doing like a robotics competition and you want to have like CAD files, and you constantly change, you're updating your files, and the whole team can look at them, and it will change all the drawings and other things for it. That's it for this tutorial. That should be enough for you to draw enough of your car to get into an orthographic projection. Again, I made up all of my dimensions. The only one that I approximately know is the size of the core flute. You should get your own rulers to get your things to accurately represent the size that they are. You might change the width. I also didn't do, your axle isn't just one. You have the white outer axle and the metal inner axle. So you should actually do those separately by just doing a cylinder and a cylinder inside the cylinder. Right, I'm going to finish this tutorial now and then I'll upload it to YouTube where you can watch it again at a slower pace at your own time. You can also watch the other class tutorial if maybe I explained something easier that way. I don't know. We'll find that out.